So today's question is state and prove law of conservation of energy in case of freely falling body. So conservation of energy means energy will be neither be created nor be destroyed. Energy can transform from one form to other form. Here we are talking about mechanical energy. Mechanical energy will be constant. So what is mechanical energy? This is a combination of kinetic energy plus potential energy. This will be same everywhere in case of freely falling body. Let us assume a mass of m is from the ground, the height h it is, and let us assume the 3 points. This is a point A and this is a point B, and here somewhere in between is point C, and the distance between C and B is taken as x, and this is remaining part of this, so this is h minus x. We need to prove that total energy at A and B and C are all are equal. So it means if these three are equal, if we prove, that means energy is conserved in case of freely falling body. As we have seen, total energy is a kinetic energy and potential energy. First we'll take a point A. Energy at A is equals to kinetic energy plus potential energy. We know the formula for kinetic energy is half mv square, and potential energy formula is mgh. Where it is freely falling body, its initial velocity is 0. Here velocity will be taken as v1, here it is a v2. So at this point A, kinetic energy is half m0 square plus mg capital H, where H is a capital H here. So this is mgh. This is the energy we got at A, and if we get the same at B also, then energy will be conserved. EB is equals to kinetic energy plus potential energy. Kinetic energy is half m, velocity at the bottom is v2 square, and the height at the bottom is 0, mg into 0. So we got half m v2 square. We need to find out v2. Let us take this point, initial velocity is 0, the final point velocity is v1, and the body is falling down. Acceleration due to gravity is plus g because it is also downside, and this is a displacement, that is h. Applying equations of motion, formula is v square minus u square is equals to 2as. This is also accelerated motion, uniform motion. So here v is v1 square minus 0, u is 0, 2, a is g, s is h. So v1 square is equals to 2gh. We need to substitute this in this, that is half m v2 square, where v2 value, sorry, this is v2 we have taken, right? So where v2 square value is 2gh, so half m 2gh, 2 gets cancels, we get this value is mgh. So energy at the B is also mgh, energy at the A is also mgh. Again we have to prove energy at the C is also mgh. So C is somewhere in between here. At this point velocity is v1, height is x. So E at the B is equals to kinetic energy plus potential energy, that is half m v1 square plus mg, height is x here, x here. So this is the initial point, this is the final point, this is the middle point. Here velocity is v1, here u is 0, acceleration is equals to plus g, and only this distance is h minus x, and this is x. We can see here this is h minus x, and substituting this equation with the uniform accelerated motion formula, v square minus u square is 2as, v is a v1 square, and this is 0 is 2g h minus x, that is v1 square is equals to 2g h minus x. So substituting this here, half m 2g h minus x plus mg x. 2 gets cancels. Multiply this mg capital H minus mg x plus mg x. These 2 gets cancels. mg h. E at the B is also same. So at the 3 points energy is same. So it says that energy is conserved. Therefore EA equals to EB equals to EC. So energy is same everywhere. Energy is conserved in case of freely falling body.